Hello student, welcome to our second lesson. In this lesson, we are going to look at charge distribution on conductors. And in here, we are going to consider different types of shapes of conductors. Now, charge distribution on the surface of a conductor depends on the shape of the conductor. When we have a spherical conductor, that is a sphere, you will find that the charge is uniformly distributed on the surface. But when you have pear-shaped conductor, you will find that the charge is concentrated at the sharp point. Or we say that at the sharp point, we have high charge density. When you consider other shapes like cuboid or rectangle or square, you will find that the charges are highly concentrated at the vertices. Also in the diamond conductors, again, the vertices carry high charge density. So we have the shapes here. We have the sphere. You can see that the sphere has a uniform charge all through, but when we have the pear-shaped, the charges are concentrated at the sharp point. Then from there we have the cuboid, and this cuboid, you can talk of the cuboid or rectangle or square. You will find that the charges are concentrated at the vertices, also in the diamond shape. Then from there, we consider a hollow object. We say that inside the hollow conductor, there is no charge. So the charge only exists outside of the hollow conductor. When we talk of a hollow conductor, we are talking of a cylinder. If you have a charged cylinder and then you put anything inside, there is no charge inside, but the charges exist on the outside of the cylinder. Then from there we have the point action. We need to define this term, and this one refers to the first loss or gain of a charge at sharp points. Remember, we have seen that the sharp point contains high charge density, and because they have high charge density, you'll find that they can either lose or gain these charges very fast. And when they do so, that is what now we call the point action. And the reason as to why they are able to lose or gain the charges, it's because there is what we call high charge concentration at those points. From there, we can demonstrate the point of action or the point action. And in here, we are going to consider a highly charged sharp conductor that is brought closer to the flame of a Bunsen burner. If you look at the diagram that we have here, our highly charged conductor is positively charged. Then, as we bring it closer to the flame, we find that the flame is blown away. We need to know the reason as to why. We have that the burning flame contains positive and negative ions because it was not initially charged. It has positive and negatively charged particles. But now, when the sharp point is brought closer to this flame, this sharp point will ionize the air particles that are in between the flame and the conductor. And when the air particles are ionized, it will have positively charged ions and negatively charged ions. Because now our sharp here end is positively charged, you will find that the negative ions will be attracted while the positive ions are repelled. And when they are repelled, they form what we call the electric wind. The positive ions are repelled and they create what we call the electric field or the electric wind, and this wind is the one that is blowing away the flame. Then from there, if the conductor is brought very close to the flame, you will find that the flame will split into two. What is happening? Remember, we have said that this flame contains positive and negative. And what is happening in here is that this charged body is ionizing the air particles around. So when you bring it very close, you'll find that the negative ions in the flame are attracted to the rod, that is our charged body, diverting part of the flame towards it, while the positive charges here are repelled. And when they are repelled, they divert part of the flame away. Thus, you find that the flame is split into two. Now this is something that you can do it at your home. You can charge a rod very strongly, and then using a candle try to do and see whether you can be able to get the same observation. Then from there we have the application of point action, and this one is applied when we talk of lightening a luster. Now before we move to the lightening a lusters, we need to know what is lightening and where does it come from. Now in the atmosphere we have the clouds. Now this movement of clouds in the atmosphere, they produce large quantities of static charges due to friction with air. So as the clouds are moving, they have the friction between them and the air particles, and by so doing they have what we call, or they gain what we call the static charges, and these charges are large amount. So the static charges in the cloud induce large opposite charges on the earth. Remember, there is charging by induction. When you bring something closer, you bring a charged body closer to an uncharged body, you find that that charged body can be induced or will gain charges through induction. Now we are saying the clouds are now charged, and because they are close to the atmosphere, they are close to the earth, you find that they will produce an opposite charge on the earth, producing a high potential difference between now the earth and the cloud. So it's like now we have electric field between them. We have the cloud that are having an opposite charge to the earth. Therefore, there is what we are calling the potential difference. Now, the potential difference makes the air particles, or it makes the air become a charge conductor. Because now we have the cloud and the earth. Between the cloud and the earth, we have the air particles. So, and we have talked of the potential difference. So when the air particles connect the cloud and the earth, those air particles are acting as conductor. They are conducting the charges. They are making the charges to flow. Now, the opposite charges strongly attract and neutralize each other, causing thunder and lightning. So note that we have said we have the clouds that are making the earth to be charged in opposite. That is, if the clouds are negative, the earth will be positive. So that opposite charges, they tend to attract one another because the two charges, they are unlike, and therefore there exists attraction force between them. And as they attract, they neutralize each other, and as they try to neutralize, we have thunder and lightning. Now, lightning may not be prevented, but we can protect it, or we can protect its damage or destruction. We can protect the damage that is caused by the lightning through what we call the lightning arresters. So lightning arresters comprises a thick copper wire with the sharp spikes at the top. Remember, we are trying to apply the point action. That is why we are talking of the sharp spikes at the top. Now, this one, the lightning arrester, is fixed vertically along the wall of a building such that now the spikes protrude above the building. So the wire is connected to a large thick copper wire, and the thick copper plate is buried deep on the earth. Remember, now we have the conductor that's connecting the spikes and the plate. So the plate is buried deep on the earth and the spikes are protruding above the building. We are going to see the diagram here, as shown here. So these are the spikes, and this is the copper plate that is buried deep in our earth. Then we have the conductors that is connecting the two. We have the copper strip. We have our building here. So in this one, we have the cloud. You can see that in our case here, the cloud is negatively charged. Then the arresters and the building, they will now assume the charges of the earth. And we have said that if this one is negatively charged, then the earth will have an opposite charge. So if it is negative, then this will be positive. And because these are sharp points, then the charges will be highly concentrated here. You can see that is how now we are applying the point action. The charges are highly concentrated at these sharp points. And now, how does these arresters work? So first of all, we have seen that arresters assume the same nature of charges as the earth. That one we have noted. And the earth is being charged through induction by these crowds. So when a negatively charged crowd passes over the arrestor, it causes the sharp spikes to become positively charged and the copper plate to be negatively charged. Remember now, this one, as you can see, the sharp points through induction, this one will be positively charged. So all the positive charges will be here and the negative charges will be repelled to the copper plate. Then after that, the negative charges on the plate is earthed immediately. So as the electrons move, remember electrons are the ones that are negatively charged. As they are repelled down here, you'll find that they are earthed. And when we are talking of earthing, it is either losing or gaining electrons from or to the earth. In our case here, the electrons are lost to the earth. Now, the high charge density builds up at the end of the spikes. We have that the charges are highly concentrated. And because they are highly concentrated, then we have a very strong field that develops between the cloud and the spikes. This one. There will exist a higher strong field between them. Now the spikes ionizes, that field ionizes the air that is surrounding. The air particles that are in between are ionized. And when they are ionized, it means we shall have positive and negative ions. And because the spikes are positively charged, they will attract the negative ions. And when the negative ions are attracted, they are conducted to the earth, or in other words, they are earthed. While the positive charges are repelled. And when they are repelled, they go and neutralize the charges on the cloud. These charges, they may not be able to fully neutralize the cloud, but because now the negative charges are repelled and earthed, then you find that the lightning will cause no harm. In other words, we are saying the arresters provide a path for the remaining charges to flow to the ground, thus protecting the building. Then from there we have the assignment. So assignment is testing what we have just learned. You can see some of the diagrams that we have discussed. So make sure that you revise and then come and attempt the assignment. So thank you, and let us meet in our lesson number 3.